Okay, so the first we have 18, yeah, in the index 5. So the HK is the first hash code, and DK is the secondary. So we will do with the first, and then we will do the secondary, if we cannot put the value in the empty slot. Yeah. Because 5 is still empty, so we decide 5 as the probe. So we put the value 18 in the index 5. Okay. Now we have 41. Okay, before. Oops. Okay, so I will also continue the attendance check. So we have 41. So before it was Itoon. 41 mode 13. The value is
2.
Yeah.
2.
2. Okay. And we need to calculate the secondary as well. Even though it is not mandatory, but we want to calculate, we have 7 minus 41 mod 7. So what is the result? 41 mod 7.
1.
Either one.
1.
1. 41 mod 7. Yeah, 1. So, sorry. 41 mod 7.
1.
No. 41 mod 7.
6.
Yeah, this is 6. Okay. So 7 minus 6. Then it is equal to 1. So we put 2. This is the result for the primary hash code. And then we put 1 as the secondary. And then we will check what is the index 1. No, sorry, index 2. In the index 2, it is still empty. So we put 41 in the index 2. Okay. Now we go to the next value, which is 22. Okay. Well, Yi Dong-yu.
Yes.
Okay, Yi Dong-yu. What is 22 mod 13?
6.
Sorry?
9. No.
9. Okay.
9, yes.
And then if we have 7 minus K mod 7, so we have 22 mod 7. What is 22 mod 7?
1. No. 6.
22 mod 7?
6.
No. I mean 22 mod 7.
1.
22 mod 7 is 1. Okay. So if we want to calculate this one, 7 minus 1, then equals to 6. Okay, that's good. So we will put 9. 9 will be the primary of hash code, and then 6 will be the secondary. And then we will go to the primary first. We will go to the first. 9, what is index 9 here? Oh, index 9 is empty. So we put 22. So the decision of the probe is 9. Okay. Go to the next one, which is 44. Isangje?
Yes.
44 mod 13.
44 mod 13 is 2. 5.
5?
Yes.
Okay, 5. Okay. Then we go to the secondary. The secondary is 7 minus 44 mod 7. So 44 mod 7. What is the result?
5. 7. 2.
2. Okay. Then we have 7 minus 2. Then equals to
5.
okay. Now
Okay.
there is very challenging. Okay. This one is 5. What happened in the 5? Index 5 is not empty. Okay. We will go to the secondary. What is the result of the secondary? Oh, we have the same value, which is 5. Then, where should we put the value? Okay, the first is 5. 5 is already not empty. The secondary also result 5. And 5 is not empty. Then how can we fill in this one? We have the J. Okay, what does it mean by J? In this case, J is a value from 0, 1, 2, and so on. In the first, the J equals to 1. Okay. So if it is 1, so we have the, we have I plus J multiplied by the decay. Okay. So if we have the I plus J equals to 0, so I is 5 plus 0 multiplied by 5 multiplied by 5, okay, mod n. So this is what we call as the double hashing. Okay. So if it is if we have the primary, we have the 5 plus 0 multiplied by 5. 5 plus 0 multiplied by 5, what is it? Yeah, of course. Yeah, still, here we have 5. Okay. And then if 5 is not empty, what happened? We will go to the next. We will do the 5 plus 1 multiplied by 5 mod n. So in this case, the first is J equals to 0. In the second case, J equals to 1. Okay. So 5 plus 5 mod n. N equals to 13. So here we have 10 mod 13. What is 10 mod 13? Isangja?
10.
10. Yes. 10 mod 13 equals to 10. And we put 10. And let's check what is the 10. Okay, 10 is empty. Then we put 44 in the index 10. Okay. Now let's continue to the next number, 59. Okay, Team UV. 59 mod 13.
7.
7. Okay. And then we have 7 minus 59 mod 7. Okay, so what is 59 mod 7?
3.
59 mod
3.
7? 3. Okay. Then we have 7 minus 3. That is
4.
4. Okay. Then we can get the primary is 7. And then the secondary is 4. And then let's check 7. Okay, 7 is still empty. Then we put 59 here. Okay. And then we go to the next, 32. Thank you, MUB. Now IMJ1. Sorry, IMJ1. 32 mod 13. IMJ1. IMJ1, are you here? No? IMJ1? No? Okay, then IMHijin.
Yes.
Okay. Then what is 32 mod 13?
6.
6. Okay. Now we have the secondary, which is 7 minus k mod 7. So k equals to 32. What is 32 mod 7?
Sorry. 4.
Yeah, 4. Okay, then we have 7 minus 4 equals to 3. Okay, so the primary out of us, we get 6, and the second we get 3. Now we want to put the value 32 in the index 6. Okay, index 6 is still empty. Then we just put the value 32. Okay. Now we go to the next, which is 31. Okay, Jin, thank you. Chang Dojin.
Yes,
Chang Dojin.
yes.
Okay, so what is 31 mod 13?
0,
Sorry,
0,
0.
yes.
31 mod 13. 0, is it true? Mod is the remaining value. What is the nearest integer for what is the nearest value that can be divided by 13? So 13 multiplied by 2, what is it?
2, oh,
26.
yes.
So it means we can just minus 31 with 26. That will be the remaining value. Okay.
5,
So 31 minus 26, then it is 5.
yes.
Okay, so that's the easy way to get the remaining value. Okay.
Okay.
Now we want to get the 7 minus 31 mod 13.
2,
Oh, sorry. No, not 30. 7. What is 31 mod 7?
3,
3. Okay. Then we have 7 minus 3. Then it equals to 4. Okay. Then we put 5 as the first here, and then we put 4 as the secondary. Okay. 5, yeah, we have the index 5. Okay, index 5 already filled with 18. Then we cannot put the value 31 in the index 5. What is the next? Okay, we have the secondary is 4. Based on this equation, okay, the first is 5 plus 0, which is j equals to 0, multiplied by 4 mod 13. Okay, so the first option is when j equals to 0, 5 mod 13, of course it is 5, but 5 is not available. So we go to the j equals to 1. When j equals to 1, the result will be 5 plus 1 multiplied by 4 mod 13. 5 plus 4, it is 9. 9 mod 13. What is the value? Chang Dujin. 9 mod 13.
Four.
Sorry.
4.
9 mod 13.
4.
No, it's not 4, but it is 9. Okay. Because 0 multiplied by 13 is 0. And there are remaining value, which is 9. Okay. So 9 mod 13 equals to 9. Let's check. Oh, 9 is not empty. Then what can we do now? Because j equals to 0 is not empty. J equals to 1 is not empty. Then we will go to the next, which is j equals to 2. When j equals to 2, then we have 5 plus 2 multiplied by 4 mod 13. So 5 plus 8 mod 13. Then 13 mod 13. What is 13 mod 13?
Zero.
0. That's right. Then we check 0. Is there any value 0? Okay, no value. Then we can put the value 31 in the index 0. So we put here. Okay. And then last number is 73. Okay, thank you, Kang Dujin.
Yes.
Chang Dong-hwan.
Yes.
Okay. So we have 73. 73 mod 13.
It's 8.
Yeah, 8. Okay. We have 7 minus 73 mod 7. 73 mod 7. What is the result?
3. 3.
Yeah. 3. Okay. Then we have 7 minus 3. And it equals to 4. So we have the 8 is the first, and then the secondary is 4. So we will check first the index 8. Index 8 is empty. And we can just put here. Okay. So this is the use of the double hashing. Okay. Now, the performance of double hashing, and then compared to the linear probing. In the worst case, search, insertion, and removals on hash table will take ON time. And then the worst case occurs when all the keys inserted into the map collide. So it means, yeah, if you need to do more time for repetition until n time, then yeah, that will be the worst case. There is one measure, we call it load factor. So the load factor is the alpha. Alpha equals to small n divided by big N. So small n means the number of values that you have, and then the n is the size. Okay. So it will affect the performance of the hash table. So now, yeah, this example is only 13. But if the value is very huge, for example, 113, okay, so yeah, you can calculate the alpha. And then what is the number that you want to put? In our case, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 in the 13 space. Okay, so we can calculate the alpha. So assuming that the hash value are like random numbers, so it can be shown that the expected number of probes for an insertion with open addressing is this one. 1 divided by 1 minus alpha. Okay. So you can check based on this one. So yeah, it's not directly 1 because we have here, we need to calculate 2 times. We need to calculate 3 times. Okay. So it's like more than 1. Okay. Then yeah, the expected running time of all the dictionary ADT operation in the hash table is O1. Yeah. So if you want to put the value with this kind of hash table in the overall, okay, so in the overall, the expected for all those things are O1. Okay. Because maybe this one, when you calculate 1 divided by 1 minus alpha, it is nearby 1. Okay. And in practice, hashing is very fast, provided the load factor is not close to 100%. Okay, so the load factor is, yeah, because if you have the number, the n, usually will not be close to the n. So it will be very fast. However, when we use the hash tables, usually it is for the small database. So it's not for big data. Okay? And then we can say this for the compilers, and yeah, it can be the browser cache. So for example, if you are using the Google Chrome, and then you want to place what site did you visit, so you can use hash table to allocate your memory. Okay. Okay, that's about the hash table. Any questions, comments? Okay, I give you one slide about hash tables review. So if you need to review the examples, so you can just do the slideshow of this PowerPoint. So I gave you the example about the separate chaining. In the separate chaining, yeah, if we have the mode 13, yeah, I give you this number. 15 mode 13 equals to 2. So we place it into the index 2. 18 mode 13 is 5, then we put in index 5. 28 mode 13 is 2, so we put in the index 2. and then we make a list in the index 2. Mode 13, sorry, 36 mode 13 is 10, so we put index 10, and so on. Okay, so we will have this kind of list. So this is the strategy with the separate chaining. So this is the result. If we are using the linear probing, so we do not allow the collision. So we want to allocate in any of the empty cells. So if it is 18, yeah, we get the value after mode 13 is 5. So we allocate in the index 5. This is index 2. This is index 9. Okay, because this is in index 5 and 5 is not empty. So we paste this 44 into the next table or index 6. 59, it is in the 7. 32, oh, it is in the 6. Because 6 is not empty, we check 7 is not empty. Then we put into the cell number 8. 31, 31 mode 13 is 5. Okay, 5 is not empty. And then we go to the next. 6 is not empty. 7 is not empty. 8 is not empty. 9 is not empty. Then we go to the empty cell, which is 10. 73, it is in the index 8, but 8 is not empty. So we check 9, 9 is not empty. 10, 10 is not empty. Then we put in the index 11. So with the double hashing, we have the additional formula to determine what is the best probe. So 18, and then, yeah, even though we have 3, but we still use the 5 to put the 18, and then 41 we put in the 2, and then 22 we put in the 9, 44. Okay, so 44 here is 18, but we need to calculate the secondary probe. Okay, so sorry, the secondary hash function in order to determine that we need to put the 44 in the index 10. And then we have 59. 59 is index 7. 32 is index 6. And then 31. Oh, we have problem. If it is 5, it's already non-empty. Okay, so we need to calculate when j equals to 1. We go to 9, but 9 is not empty. So we go j equals to 2. So j equals to 2, then the result is 0. So we put 31 index 0 because 0 is empty. And then finally 73, we can put it into the index 8. Okay, so that's the review. You can take a look on this PPT for further study. Okay. So I will continue the next chapter, which is graph. So if I take a look on your team project proposal, so there are like 3 or 4 teams who want to do this kind of graph. So I think this chapter will be very good for you to understand about this algorithm. Okay. So we will learn about graph and terminologies, and then we will learn about the graph ADD and some implementation. Yeah, maybe on Monday I will explain all the source code from the Python. Okay. So in this section we will learn about graph. So graph is a pair of V, E. V is a set of nodes, or we call it vertices. E is a collection of pair of vertices, or we call it edges. Vertices and edges are position and store elements. Okay. So you will use graph in many applications. For example, we have a vertex. Okay. The vertex represent an airport. So like this one, H and L. H and L is for the Honolulu. Okay, SFO. SFO is for the San Francisco. Okay. An edge represent a flight route between two airports and store the mileage of the route. So we go from Honolulu to LAX. LAX is from is Los Angeles. Then we will have about 2,555 miles. We can go from Los Angeles to San Francisco. The mileage is about 337. So this is a graph. The node represent one location, for example, and then the edge represent the distance or the mileage, or sometimes it can be the cost. So anything about the relationship between two vertex. So we call directed edge. Okay. Directed edge means we have a direction, or we can say this is order pair of vertices. So U is the origin and V is the destination. So in this case, we want to go from ORD to PVD. What is it? ORD. ORD is O'Hare Airport in Chicago. And then PVD is Pennsylvania. Okay. So we will go from the Chicago to Pennsylvania using the flight number AA1206. So we have the direction. That's why we call it, this is the directed edge. So there is a direction. So in this case, ORD is the origin. Okay. So this is the origin, and PVD is the destination. The second one, we need to learn about the undirected edge. Undirected edge means there is no order. There is no difference. It means if there is an edge like this one, there is no arrow. Okay. So here you can see there is an arrow here. So we go from ORD to PVD. But in the second one, there is no direction. We call it, this is undirected edge. The undirected edge, maybe we can say it as a flight route. So this flight route, there is a route from ORD to PVD, and from PVD to ORD, maybe they also have the route. And the miles or the mileage is 849. Okay. Based on the edge, based on the edge, we can mention about the graph. Okay. So the directed graph means all the edges are directed. So if you can see all the edges are an arrow like this one, then yeah, you can see this is the directed graph. If it is undirected graph, it means all of the edges are undirected. So for example, the flight network, yeah, it can be also undirected graph. There are many applications. Okay, if we are in the computer or if we are in the electronic departments, we can say that the electronic circuit is one of the application of the graph. So you can see the printed circuit board. In the circuit board, you can see the connection between the electronic components, or IC, integrated circuit. So we have the connection between components. So we can see it also as a graph. Transportation network. So if you are in the domain of supply chain, so you will learn about the networks from supplier to distributor to the warehouse to the consumer. So we can also see like the highway network, flight networks. The computers also has network. We can have the local area network. We have the internet connection. Okay? One internet is connected to another connection. Okay? Web. You can have the link, one link connected to another link. Okay? Or for example, database. Database also can be seen as a graph. So there are some terminologies. Okay? We call it end vertices or endpoint of an edge. Okay? If, for example, like this one, U and V are the endpoints of A. A is the name of the edge. U and V are the endpoints of A. So if you have like node, and then we have other node, and then we have this connection, let's say this is A, and then this is B, and then let's say this is, we want to say this is X. Okay. So the endpoint of X is A and B. Okay. The next is edge incident. What is the meaning by incident? For example, A, D, B are incident on V. A, D, P. They are incident on V because the edge of A, the edge of D, and the edge of B is connected to V. Okay. Now let me Kang Dong Hwan. Oh, I think you already. Son Soo Jong.
Yes.
Okay, Son Soo Jong. Now I would like to know the edges incident of W. What is the edges incident of W?
C and T.
Yeah. C, D. That's all. What is
E,
what are the edges?
C, D, E, F.
Okay, that's correct. C, D, E, and F. Okay. So any edges connected to the vertex, we call it edges incident. Okay, thank you. Now we have another terminology. We call it adjacent vertices. U and V are adjacent. U and V are adjacent because it is connected with one edges. Okay. Now I would like to call Han Jung-won.
Yes.
Okay, Han Jung-won. True or false? U and Y are adjacent.
False.
False. Okay, that's true. So it's false because U and Y is separated by
W.
W. Okay, so it is not adjacent. but U and W, they are adjacent.
Yes.
Thank you.
Thank you, Professor.
So, wait, I want to know Im Jae-hyun. Im Jae-hyun, are you here? No? Okay. So, we go to the next. Degree of a vertex. X has degree 5. How? We can calculate this one. So, we have 1, 2, 3, 4, 5. Okay, so every edges in that node, we can calculate. Now, Sim Doksu, are you here? Sim Doksu? No? Okay. The next is parallel edges. The parallel edges means we have the same node for two edges. For example, here we have X and I. Because these two are parallel because they have the same vertex, X and Z. So they are parallel. Self loop. So J is self loop. Okay, so we can say this one. The node is the same for the endpoints. Okay, so the endpoint of J are Z. Okay, so that's what we call as the self loop. Path. We need to understand the path and cycle. Okay, so the path means it is a sequence of alternating vertices and edges. It begins with a vertex and then it ends with a vertex. And its edge is preceded and followed by its endpoints. We call it is a simple path when the vertices and the edges are distinct. Okay? For example, we have P1 starts with V and then ends with Z. So we have V and then we go to B. B is the X. Okay? And then we go to the node X. And then we go to the edge H. And then finally we go to the vertex Z. So this is a simple path because all vertices and edges, they are distinct. Distinct means no no same vertex, no same edge. P2. P2 is also a path, but let's check. We start from U and then end in V. So we will go to C, U go to C and then W. And then the W, we go to X through E. And then we go to Y through G. And then we go to W back through F. And then we go to V through D. Okay. We call this is the path is not simple. Why? Because W visited more than one. So this is not distinct. Okay. Distinct means different. So every node should be different. Every edge should be different. Because we visited W twice, then it is not different. That's why this is a path that is not simple. Cycle. Cycle means is a circular sequence of alternating vertices and edges. And its edge is preceded and followed by its endpoint. Okay. We have also simple cycle. The cycle such that all its vertices or edges are distinct. Now let's see C1. So based on this one, it is a cycle is starting from one vertex and then it will return back. So V is the starting, and then it goes to X through B, and then it goes to Y through G, and then it goes to W through F, and then we go to U through C, and then we go back to V via A. So the last symbol means it is this is the ending. Okay, this is the ending vertex. So it is a simple cycle because all vertex and all edges are distinct. They are distinct. They are different. However, the cycle that is not simple, if you check this one, U, we start from U, and then we go to W through C, we go to X through E, and then we go to Y through G, we go to W through F, we go to V through T, and then return back to U. Okay. So it is not simple because we have W and W here. So we visited W twice. Then it is a cycle that is not simple. So some of the properties in the graph, you can take a look at this one. We have N represent the number of vertices, and M represent the number of edges. Degree of V. So it means the degree of vertex V. In graph, we have two kind of properties. The first property is the summation of all the degree V equals to 2 multiplied by M. Let's see this graph. So this graph, we have N equals to 4. Okay, N is the number of vertices. And then M equals to 6. Okay. M is the number of edges. 1, 2, 3, 4, 5, 6. Okay. Now, the degree of V. What is the degree of V? This vertex, we have 1, 2, 3. So the degree is 3. What about this vertex? We have 1, 2, 3. So 2. What about this vertex? We have 1, 2, 3. What about this vertex? We have 1, 2, 3. So every vertex have degree 3. If we evaluate with this property, so the summation for all V, the degree will be equal to 2 multiplied by m. What is 2 multiplied by m? 2 multiplied by m equals to 12. Okay. And then the summation for all the degree of vertex. So vertex 1 is 3, and the vertex 2 is 3, the vertex 3 is 3, and the vertex 4 is also 3. Then it is 12. Okay. So that's why the property 1, we will calculate the number of degree of every vertex. We will do the summation, and it will be equal to the number of vertex multiplied by 2. What is property 2? So if it is an undirected graph with no self loop and no multiple edges, so the property will be m is less than equal to n multiplied by n minus 1 divided by 2. So it means like 4 multiplied by 4 minus 1. So multiplied by 3 divided by 2. So it means 12 divided by 2, then 6. Okay. Now we have m equals to 6. Okay. So 6 is less than or equal to 6. It means, it is still based on this property too. So I think this one is the maximum number of edges is m. That's why we have the equality sign. But it can be less than this number. So here the maximum is 6, but it can be less than 6. So this one, the proof is when each of the vertex has degree at most n minus 1. So here, the degree of the vertex has n minus 1. So we have n equals to 4 minus 1 equals to 3. Okay. What about if it is the directed graph? Okay, there can be another properties for this one. Okay, so maybe we can take a look later. Okay, I think I will stop here because of the time. So any questions, any comments?